All right, guys, we are on Unit 4, Day 8. This is actually our last day of notes in this packet. So we'll be moving to Unit 5 after this. And in the warm-up, it's talking about the diagram below. A square is graphed in the coordinate plane, and a reflection over which line does not carry the square onto itself. All right, so in number 1, that would be a reflection over x equals 5. And so we're going to talk about that Vooks. This is going to give us a vertical line at 5. So 1, 2, 3, 4, 5. Right there is the line x equals 5. And if I were to flip this square over the line, I don't think it would carry onto itself, which makes me think that that's the right answer. But let's double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Actually, would go right off the graph. But your square would look like this after a reflection over x equals 5. And that's not onto itself. So I'm thinking that this is our answer. But let's double check. In number 2, y equals 2, you should be thinking of Hoy. Y equals 2 is a horizontal line. All right. And I think you guys can see that the top of this square would flip down and reflect to the bottom, and the bottom would reflect up to the top. And so the top of the square and the bottom of the square really just reflect onto itself, and you end up with the same square that you started with. And so choice 2 is out. Okay? Y equals x is that nice diagonal line that cuts through the origin. Okay? And I think you guys can see here that this part of the square would reflect down here, and this part that's down below the line of y equals x would reflect up, and it would be the same exact square. Okay? On the last one there, you would have to do a little maneuvering to see what this line looks like. Get it into y equals form by subtracting the x. Okay, and so that's a y-intercept of positive 4. And you're going down 1 over 1 for a slope of negative 1. And you're going to see that that line of reflection cuts the square diagonally the other way. And so this part of the square would reflect up and come over here. And the part that's above that line would reflect below it. And so the square would stay on itself. And so choice 1 is our answer. Okay. All right. So we're going to talk about a composition of transformations today. And they occur when 2 or more transformations are performed one after another. And the first transformation produces an image, and the second transformation is performed on that image. In compositions, we never go back to the original. Never go back to the original. All right? You always perform the second transformation on the one you just got. Okay? There's notation for composition. They can be written 2 different ways. In one, you can use this little symbol. It's called an open circle. It looks like a degree symbol, but it's not up in the air. It's kind of like on the same line of writing, and so it means following. All right. And so when they use that open circle, if you read it, this is a translation of 2, 0, which means 2 units to the right. The open circle is read as the word following. And then this is a reflection over the line y equals x. Well, if you've ever played follow the leader, if you're following someone, you're coming after them. And so if the translation is following the reflection is going to go first, and then the translation will be done secondly. Okay? So since the translation is following the reflection is performed first, then the translation. But most people reading this would do the translation first if they don't know that the open circle means following. So be careful. Okay? They could also use 2 sets of parentheses where they group it with an inner set of parentheses. And you guys can see that this is grouped with the A that's in the parentheses. And so this would be done first and then the translation. So these 2 notations actually make you do the same transformation first. So if you can remember that part, that should be easy. Okay? All right, here we go, guys. In number 1, it's going to ask us to find the image of A, who's at positive 3, negative 2, under the given composition of transformations. So what this says is that it's a translation following a reflection over the y-axis. Therefore, in order for the translation to follow the reflection is going to have to go first. Okay, so I'm going to go find 3, negative 2. This is my starting point, and I now have to reflect it over the y-axis. So keep in mind my y-axis is right here. If I were to reflect A over it, I would end up 3 units on the other side, and I would end up right here, and that would be A prime. And the coordinates would be negative 3, negative 2. All right, so after the reflection, I end up at negative 3, negative 2. Now I'm going to go ahead and on that point, I'm going to go ahead and translate it. And so this translation means 2 to the left and 4 up. So I'm going to take the point I just got and go 2 to the left and 4 up. And I'd end up right here, and that would be my final spot. And so that coordinate will be my answer as soon as I find it. So that would be a 1, 2, 3, 4, 5. Negative 5, positive 2. We're going to box that up. And that is the image of 3, negative 2 under the composition of transformations that I was given. Okay. All right, let's try another one. In part B, they're asking me to do a rotation around the origin of 180 degrees following a reflection over the x-axis. So in order for my rotation to follow my reflection has to be done first. Okay? So I'm going to go back and find 3, negative 2, same starting point that I gave in the original problem. But now we have to reflect it over the x-axis. So our x-axis is here. And if I reflect my point over it, it'll be 2 units above it. And my coordinates would now be positive 3, positive 2. All right. Now I'm going to go ahead and take that point and I'm going to rotate it around the origin of 180 degrees. So hopefully you guys remember how to do this. We're going to take the top of our paper. We're going to turn it twice to the right for 180 degrees. Okay. And with my paper graphed, flipped upside down, I'm going to graph positive 3, positive 2, the point that I just got. And it would be right here. Okay. I know my A looks upside down, but it's not. But now it is when I flip my paper back. And the coordinates of that point are negative 3, negative 2. And we're going to box that up. Okay. We have one last one. They use the same exact notation. So it's a reflection over y equals x following a rotation around the origin of 90 degrees. In order for my reflection to follow my rotation must be done first. Okay, so I'm going to go find 3, negative 2. This is my starting point. And now I'm going to go ahead and rotate that point 90 degrees. So I'm going to grab the top of my paper, turn it once to the right for 90 degrees. And with my paper sideways, I'm going to go ahead and regraph 3, negative 2. So 1, 2, 3, negative 2 would end up being right here. And that's what the point would look like after rotation of 90 degrees around the origin. And it would have coordinates of positive 2, positive 3. Okay. And now I'm going to go ahead and take that point and I'm going to reflect it over the line y equals x. So y equals x is that diagonal line. It cuts through the origin. And this is the one where you have to count diagonally. And you guys can see that my point is only half a block away from the line of reflection. So I'm going to go half a block over. And right here is going to be where I end up. Okay? And the coordinates of that point are positive 3, positive 2. And there is my final coordinates. Okay? All right, we'll go talk about a few more things on the back side, and I'll see you guys there.